Okay, so for this next video, we're going to take a look at the Towers of Hanoi problem. So I've got the code for this one opened up already. As you can see, just looking at the overall size of it, that the code overall looks fairly simple. As soon as I get into this though, once we start talking about the different recursive calls we have to make, passing in these 5 different parameters, this explanation that I'm going to have to give is going to be anything but simple. To start off with though, to make sure that we fully understand what this program is going to be doing, I want to make sure that we actually understand what this Towers of Hanoi problem actually is. So there's a possibility that you've played some variation of this game before, where essentially you've got a set of disks of different sizes, usually 3 of them, and you're given 3 pegs, and you have to be able to move the disks in increasing order. So you got your smallest disk, and then your middle-sized disk, and then your largest disk in that order, and you need to be able to move them from one side of these pegs to the other side. So to demonstrate how this works, I have a simple program. So you can find this on this website, Math is Fun. They have a little setup for it, so like a simulation that you can do for it. So you've got your 3 pegs, and you got your 3 disks of different sizes. So we need to be able to move these 3 disks that are on this peg over to this right peg over here. So to do this, what we want to do is make sure that we are moving each one of these pegs one at a time from or each of these disks from one peg to the other. So we can go from this first one all the way to the rightmost peg. And one of the rules we have to keep in mind is that if we take one of these disks, we cannot place it on top of a smaller disk. So if I do that, it's not going to let me. So instead, I want to go ahead and move that to ideally another vacant peg. So let's go ahead and put it in this middle one. And then the objective here is to try to accomplish this in the smallest number of moves possible. They actually give you a little hint right here telling you that if you do this with 3 disks, the minimum number of moves should be 7. So I've used up 2 of them so far to be able to move these 2 pegs, or these 2 disks to each of these 2 pegs. So to go ahead and solve the rest of this, I'm going to go ahead and take the smallest disk, move this to the middle peg, take the largest disk, move this to the rightmost peg, take the smaller disk, move this to the leftmost peg, take the middle-sized disk, place that on top of the larger disk, and then take the smallest disk and place that right on top. Okay. So the objective of our program is to be able to essentially replicate that set of moves that I just made in order to move these 3 pegs from one side to the other. So if we go ahead and take a look at this, we are going to be able to specify the number of disks that we want to use. So go ahead and specify that here. The 2 values that we have right here, we're going to pass in the number of disks for our move disks method, which is going to be the recursive method that we need to use in this program. And then in addition to that, we've got 3 numbers right here. These 3 numbers are going to be used to represent which peg we're moving through. So we got the very first one right here is going to be our from peg. So this is basically saying where the disk is coming from. We've got a to peg, so this is describing where the disk is being moved to. And then we've got a temp peg, which is basically just the leftover peg. Okay. So to start off with, we've got 1, 3, and 2. So no matter how many disks we use, the very first move that we're always going to be making, if we come look at this, go ahead and restart it, we're always going to be taking something that's in peg 1, this leftmost peg, and moving that over to peg 3, this rightmost peg, and so then the leftover, the temp peg, is going to be 2. So we're always doing this order of 1, 3, 2 on our very first call. And then for the remainder of them, well, essentially that's going to be dependent on precisely where in our steps through solving this we happen to be. The ordering of these pegs is going to change as needed, essentially describing which one's going to be the from peg, which one's going to be the to peg. Say for example on the next disk, the from peg is still going to be 1, but now our to peg is going to be 2. And if we take a look, we can actually see right here, our from peg is the 3rd parameter. The order of that's going to stay the same in this first call to move disks right here, but our temp peg and our to peg, these 2 are going to swap positions because of the fact that now I had to move this to the second disk, or the second disk I had to move to peg 2, and now peg 1 became my temp peg. Okay. So The next thing I've got right here is going to be a print statement. I'm going to be using this to keep track of which step I happen to be on. As soon as I run this program, you'll actually see this just print out the 7 steps that it takes to solve this. So I'll go ahead and restart this and very quickly just describe each one of these steps in terms of the numbers for the pegs. So in step 1, we're going to go from peg 1 to peg 3. Then we're going to go from peg 1 to peg 2. We're then going to go from peg 3 to peg 2. We're going to go from peg 1 to peg 3. We're going to go from peg 2 to peg 1. We're going to go from peg 2 to peg 3. And then we're going to go from peg 1 to peg 3. Okay? So keep that in mind when we run this in a moment. And then finally right here, we've got a second call for move disks. And this is going to be kind of the, you can think of this as kind of the inverse as we step through this. So we have to make 2 calls. One is moving them in one direction, and then the other is being able to move them in the other direction. So think of it in terms of like which ones are moving it from left to right, and which ones are moving from right to left. Okay. So now we'll come over here. We'll go ahead and compile this. So this is going to be our towers of Hanoi.java. And then go ahead and run this. And then we'll ask for the number of disks used. So for this one, we're going to go ahead and do it with 3 disks. So we'll run that, and then we'll get those 7 statements to print out. So if you recall what I just described when I did it with the simulation, we're moving disk 1 from peg 1 to peg 3, moving disk 2 from peg 1 to peg 2, moving disk 1 from peg 3 to peg 2, moving disk 3 from peg 1 to peg 3, moving disk 1 from peg 2 to peg 1, moving disk 2 from peg 2 to peg 3, and then moving disk 1 from peg 1 to peg 3. Okay, so the sequence of steps right here is going to match up with that sequence of steps that we had in our simulation. And then of course if we run this with even more of them, so we do this again, we put something like 4 disks, we run that out, and now we can see this print out each one of the different steps for that one. And then if we come over here to the simulation, we can actually check it here as well. So we'll move this up to 4 disks. We'll see the minimum moves is going to be 15 now. If you want to take a moment to count through all these steps, you'll see that there are 15 steps here that we need to go through. And then we can also just go ahead and use the solve button and let it just run for itself and see it actually solve out the entire problem for us. Okay. So at this point, this is going to wrap up everything for the Towers of Hanoi problem. Just taking a quick look at the setup for this recursive method, trying to step through this move disks method and what the expected output for this program is meant to be. Going into the next video, I want to wrap up on recursion by taking a look at a recursive graphics method with the Sierpinski's gasket or Sierpinski's carpet problem.